Hello students, moving on to the next topic in computer organization, that is memory location and address. So each and every individual, each and every one of you has got your own address, yes or no? Just think, if it is a class of 10 students or 100 students, irrespective of the number, each and every person is addressable. In the sense, each and every person has got a unique identity. It can be your USN, right? No student names can be same, right? Names could be same. So if person A and person B may be having the same name, but the identity, that USN will be unique. So each and every individual accessible with respect to that unique ID, right? So in the same way, each and every data what you are going to store in a system is accessible. If it is accessible, in the sense it should have a unique identity or unique location value. That location value is called as addressing, right? Just analyze the meaning of address. Your name will be there, your parent name will be there, then place name or location name will be there, isn't it? Then code, pin code or zip code, whatever, that information will be there, right? They are all the unique identity, and they all create the unique identity or addressing. So in terms of a computer, each and every data should be accessible, or it should be identifiable as particular location. That certain location, what we are saying, is called as addressing. So the memory consists of many million of storage cell, each of which can store a bit of information. One bit of information, bit in the sense either bit in the sense a binary value, either it can be 0 or it can be 1, right? Each group of n bits referred to as word information. First, before to word, we need to consider the byte. Set of 8 bits will give you 1 byte. Similarly, set of 4 bytes, 3 bytes or 4 bytes, depends on the machine architecture, will give you a word. WRD, word stands for. So word length can vary from 8 to 64. That's why depends on the type of the architecture. Word length can be 8 bit or 64, even 64 bit. But byte, its length is fixed. 1 byte equal to 8 bit. Set of 8 consecutive bits will give you 1 byte, and set of bytes will give you word. That depends on the machine architecture, right? This is how the main memory addressing is done. So it looks like a table. You can see the rows, horizontal and vertical lines. Somewhere vertical lines are marked. Actually vertical lines will be there everywhere. Just think, it's a table, how table structure looks like. Your ruled page you just open, right? It looks like a table only. Left hand side there is a margin, consider that as one column, and right hand side you are writing the contents over there, think it as the second column, right? It looks like a table. So memory is like a tabular structure. It will be having different rows and columns. Please remember, each row represents one word. What each row represents? Each row represents one word, WRD. Please make a note of it. Each row represents one word, and each column which represents one byte, okay, or bit also. Even we can represent them in terms of bits. That is what represented here. Set of 32 bits will give a word as per this format. So rightmost bit, that is least significant bit, and leftmost bit will be most significant bit. Rightmost bit, least significant bit, is identified with an ID B0 to most significant bit Bn minus 1. So B0 to Bn minus 1, where B0 is LSB, Bn minus 1 is MSB, which gives you a word, okay, word of I. So word of 0, word of 1, word of I will be the last one. word of 2k minus 1 is the last one as per this, let it be. So first row is identified with 0 leftmost, check the address value, hope it is visible. Check the address of first row address leftmost value is 0, which is marked as word 0. As you can see, n number of bits are there in each row, this represents n bits. This is the word length, n bits is called as the word length. Okay, then first row again, word 1 it is marked as, again it has got the same length, that is of n bits, and each bit is accessible. So b0 is the of word I, you just consider b0 to be n minus 1, various bits are marked. This is what the main memory address is. Okay, the length of the or size of the memory depends on the architecture. So please remember, this is again one of the important topics. Please go through carefully, go through the content, pause the video, note down the things. Okay, hope the things are visible, note down them. Okay, next we have to see the types of addressing or ways of addressing. Let's see what it is. This is what the word length of 32 bits marked, b0 to b0, b1 till b31. b31 in case of signed number, the MSB, b31 is MSB. Observe clearly, observe carefully. Out of 32, the 32nd bit, that is b31. b31 is the last identity, last bit identity, because leftmost bit identity, because of what? Because of this is the MSB, and b0 is the LSB, least significant bit. So most significant bit in case of signed number, in case of integer representation, the MSB, which represents the sign value. It can, if MSB is 0, that b31 value is 0, it represents positive number. Otherwise it represents the, if it is 1, it represents the negative number. Remaining bits are used for the magnitude purpose. And character representation, 8 bits are used to represent a character. Please remember, for integer representation normally we use 32-bit representation, that integers are converted into binary pattern of using 32 bits. In case of character, only 8 bits are sufficient. So one word can store how many? See here, set of 4 bytes are marked, where set of 4 bytes, right, where each byte is capable of storing 1 character. Please remember, size of character is 1 byte. So in a row which contains how many bits? 32 bits, which is equal to how many bytes? 4 bytes. That is what marked here, 4 characters, right? 8 bits, set of 8 bytes, you can see ASCII characters can be stored. Okay, and machine instruction, it contains the opcode as well as register values. So out of 32, 8 bits are right from MSB, right? 8 bits are used for representing the opcode. Recall the previous concepts, that 2 instruction load and add instruction what we have taken earlier. Watch my previous videos again and observe. Okay, and addressing information, remaining 24 bits, that is the register information or location information that will be represented here. Okay, please go through the description, the same thing what I told, which is there here. So byte addressability, it is called as, there are, for byte addressability, see, each and a memory which has got a tabular structure, as I said earlier. So broadly the table, which each row represents a word and each column broadly represent a byte. Okay, normally in case of each column, so each row may contain 4 columns, 4, that depends on the, as per this discussion we are considering a row with 4 columns, where each column represents a byte. There are 2 types of addressing, byte addressing. big endian method and little endian method. So we can address the byte from left to right or right to left. One is called as right to left, left to right is called as big endian method, and right to left is called as the little endian assignment or method. Let us see the diagram. Please note down all these things. See the diagram. See here, this is the diagram. So byte address, left hand diagram and right hand diagram, there are two diagrams available. So byte address on top, it is marked, and word address. Byte addresses are what? As I said you earlier, it's a tabular, memory is a tabular structure which contains row and column. Each row is marked as one word, each column represents a byte. So set of 4 bytes give you a word here. So what happens? Word 0. Word 0 contains what? Leftmost value of that is 0, 1, 2 and 3. Word 0 contains what? There are 4 bytes, right from 0 to 3, left to right, isn't it? Then 4, next row it is marked as 4 because this you need to be careful. Next, word address, that depends on the first byte of that word. What is the first byte of the word? First byte value is 4 only, please remember. Okay, similarly next row word address will be 8 because first byte of the next word is what? Its address is 8. So left to right scenario is called as big endian method or big endian assignment. Just reverse it, it is called as little endian. Right to left you take. Word address remains same, but byte addressing is done from right to left in reverse way, which is called as little endian. One of the very important topic from this module. Word addressing methods. Okay, byte addressing and byte addressing and word addressing, there are 2 ways of assignment. One is little endian assignment, other one is called as the big endian assignment. Okay, please go through these descriptions carefully. I'll be sharing the notes in the group as well. Please go through the notes carefully. If you have any doubt, feel free to ask. See you in my next video.